BLACOH pulsation dampeners should be used on every type of positive displacement pump, depending upon the application. I'm going to demonstrate for you how a BLACOH dampener can be used on several different applications and with various types of positive displacement pumps. This first demonstration is comprised of a 1/2-inch air-operated double diaphragm pump fitted with a BLACOH pulsation dampener with the adjustable air control on the pump discharge. On the inlet side is a BLACOH inlet stabilizer fitted with the J air control. There are 3 keys to pulsation dampening. They are size, location, and charge. The size of the pulsation dampener is based on type of pump, volume per stroke of the pump, and the desired percentage of dampening. Location should be as close to the pump discharge as possible within 10 pipe diameters. The dampener should not be mounted on any branches or any type of risers. You want it as close to the fluid flow as possible. The third key component is the air charge. An overcharged dampener will not be effective. The air charge internally should be a few pounds less than the pump discharge pressure. Remember, compressed air or clean, dry nitrogen can be used to charge the dampener, but never use oxygen. On installation, the dampener can be installed horizontally or upside down as pressure is equal in all directions. Vertical is the preference, especially with a slurry or a solids-laden product. For this test, I am going to overcharge the dampener, which turns it off. When I turn the pump on, you'll see the pipe shaking, vibrating, and a pulsing flow. This flow comes from the pump by itself without the dampener. Pipe vibrating, pulsating flow that is foaming and splashing the product. Now I'm releasing the air that's inside the dampener, and I'll begin to tune it in. And when I bring it in within a few pounds lower than the discharge pressure, you see the pipe lays flat, nice smooth laminar flow, no splashing or shaking. By eliminating the pulsating flow, the pulsation dampener protects system piping from fatigue, protects gauges, enhances meter performance, protects transducers, switches, protects filter media, filter bags, and any other inline instrumentation. Whereas the discharge pulsation dampener protects the system components and piping, the inlet stabilizer protects the pump, its components, and the inlet piping or hose. In this demonstration, we have a small suction lift application. As the pump strokes, the inlet ball valves open and close, creating a water hammer effect, much like a quick closing valve. So as the pump strokes, the acceleration head is created towards the pump. The ball valve closes, stops that flow, and reverses it. On the next inlet stroke, the pump must overcome that pressure wave going backwards because of suction lift and re-energize the fluid forward into the pump. That causes a lot of stress on the pump and its components, including the diaphragms, and bounces around the inlet piping and hose. To demonstrate this, I'm going to put a little extra head on the discharge since we have a very short suction lift. The greater the differential of pressure between the discharge and the inlet of the pump, the more rapid and positive the seating of these ball valves will be, creating a more violent pressure spike. To demonstrate the inlet stabilizer, I'm going to overcharge it and remove it from the system. Now, as I turn the pump on, you will be able to see the pressure wave going back down the piping system, and the pipe will be shaking, and that's the pressure shock created when the ball valves close. So again, as those ball valves close, it sends a shock wave down the inlet piping. Now, with the unique J model, I'm going to take the air pressure out of it and pull a slight vacuum on the bladder. By pulling a slight vacuum, we created a small reservoir for the water hammer shock wave to go up into, absorb it, and a nice accumulator for the pump to draw liquid from. Now you can see that the water hammer spike has been eliminated and the system is running efficiently and the pump is at its maximum performance. If we had a positive inlet pressure in the pump, instead of pulling a vacuum in the stabilizer, we would put a positive pressure in it.